So hey guys, welcome back to my channel. Now we'll be solving another question that came today in today's exam JEE 2026 shift 1. This question belongs to inverse trigonometry and the relation function domain part. The function given here is cos inverse 2x minus 5 upon 11 minus 3x plus sin inverse 2x square minus 3x plus 1. तो जैसे हमने डोमेन वाले चैप्टर में पढ़ा है, जब दो फंक्शंस का सम दिया हुआ है, सो वी विल हैव टू फाइंड द डोमेन of this function and this function separately and then find the intersection of the range of the domains that we get separately. The intersection of both the domains will give us the final domain for the function f of x. So let's first focus on cos inverse 2x minus 5 upon 11 minus 3x. Whatever, if the function is cos inverse of something, this something should belong between minus 1 and 1. So according to this 2x minus 5 upon 11 minus 3x should lie between minus 1 and 1. That's what we know. Cos inverse, if we have a function of cos inverse t, the parameter t should be between minus 1 and 1. That's the domain for a normal cosine inverse function. So now we have this. We can write this as 2x minus 5 upon 11 minus 3x mod less than 1, because this lies between minus 1 and 1, so the absolute value of this would be between 0 and 1, which we can write as modulus of this less than equal to 1. We can simplify this as 2x minus 5 mod less than equal to 11 minus 3x mod. Squaring both sides, the mods will be removed. Inequality sign would remain the same. We'll get 4x square plus 25 minus 20x less than 121 plus 9x square minus 66x. Simplifying this, we'll get 5x square minus 46x plus 96 greater than equal to 0. When we'll simplify this, we'll solve this quadratic. We'll get two factors. X minus 16 by 5 into x minus 6 should be greater than 0. We took 5 common from this, so we got x minus 16 by 5. We'll plot this using wavy curve method. This is minus infinity, this is plus infinity. We have 2 points, 16 by 5, which is 3.2, and 6. We need the value to be greater than 0, so it will be plus minus plus. So for this to hold, x should be between minus infinity to 16 by 5, close bracket, because we have a equal to sign with 0, union this part, first this part, then union with 6 to infinity. 6 would be closed, infinity, as we know, would always be open. This we got the domain for the first function, which is cos inverse. So now we'll focus on the second part, which is sine inverse. I'm writing on the same page because this question is a bit long. We have space congestion, so I'll focus for the second function on the same page on this corner. We have the second function sine inverse 2x square minus 3x plus 1. Same thing holds for sine inverse also. The argument that is given inside should lie between minus 1 and 1. Taking these two inequalities separately, here we'll get 2x square minus 3x plus 1 greater than equal to minus 1. Here we'll get 2x square minus 3x plus 1 less than equal to 1. Here we'll get x, so taking x common, we'll get x into 2x minus 3 less than equal to 0. Here we'll get 2x square minus 3x plus 2 greater than equal to 0. For this quadratic, the roots that we'll get for this one are imaginary. D is less than 0, discriminant. So the value of this quadratic would always be greater than 0. So x here would belong to R. Any value of x would give this quadratic equation's value greater than 0 always. So for all x in R, this would hold true. Solving this one on the wavy curve again, we'll get 2 points, 0 and 3 by 2. Now since we need the value to be less than 0, so applying wavy curve, we'll get this area, which will give a value less than 0. So for this function, the domain would be x belong to R, intersection with x belong to 0 to 3 by 2, which gives us a net domain as x belong to 0 close bracket 0 to 3 by 2. Now we have the domain for both the functions. For cos inverse 2x minus 5 upon 11 minus 3x, we got the domain as x belong to minus infinity to 16 by 5 union 6 to infinity. And for sine inverse 2x square minus 3x plus 1, after finding the two domains separately for both of them, we got the net domain as x belong to close bracket x belong to 0 to 3 by 2. Now taking the common area between these two, we'll find that the net domain for both these functions combined should be 0 to 3 by 2. So as we are given in the question, the domain was a to b. So here value of a would be 0, value of b would be 3 by 2. So the value of a plus 2b would be 0 plus 2 into 3 by 2, which would be 0 plus 3, which is equal to 3. So the correct option would be B. Option number B, C. Thanks for watching.